x. We had the same example in class, but with cosine. So this is 1 minus cosine 2x divided by 2, everything squared, which will be, when we square binomial, 1 minus 2 cosine 2x plus cosine squared 2x. We separate into 3 fractions. 1/4 minus 1/2 cosine 2x plus 1/4. And we replace this again by 1 plus cosine 4x divided by 2 from the same formula that I just showed you in the previous notes. And it's done. So we have 1/4 minus 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x, and we have to add these two. These are the only ones that are like terms. So this is 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. And this is it, and no one can further simplify it. Good. Other questions for me? Is there anything else? Is there anything else we want to look at? Anyone? Is this okay? Everyone, please.
Yeah.
Perfect. Okay, so I'd like to go to the handout. I also have it here in the background, if I can find it now. Yes, I have it. Let me share my screen.
Can I see the paper, like the whole paper, the whole equation that you did?
Sorry?
You move the paper down so I can see the
Oh, yeah.
Thank you.
Okay, so let's share here. And we looked at these types of problems, but we haven't looked at any of these. Use the half angle identity or formulas to find the exact value of each expression. Any preference? Anyone, please? Any preference?
Can we do 28?
Yes. I would like also to do 24, and we'll do also 28. Let me copy them here. Tangent 9 pi over 8, and the other one is cosecant 7 pi over 8. Perfect. Okay, so why I wanted to also show the tangent 9 pi over 8 is because we can take the integers out. What does that mean? See, here 7/8 is less than 1. But here 9/8 is more than 1. So what I would like you to remember with this one is that when we are asked to find tangent 9 pi over 8, I will always first write tangent pi plus pi over 8, because 8 plus 1 is 9. So I took the integers out. Basically, what I did, I said 9/8 is one integer and 1/8. One integer and 1/8. Why did I do that? Because I know that tangent pi plus an angle is tangent alpha. How come? The period of tangent is pi. So tangent of pi plus alpha will always equal alpha. For the functions that have period 2 pi, so like sine, 2 pi plus alpha will be sine alpha. So therefore, I don't have to worry about this. I can always determine, in this case, I can determine tangent pi over 8. So I'm going to jump over all this explanation and continue here. Stop me if you have questions. Is this okay so far? Let's take a moment. Is this okay so far? Yes? Any questions? Anyone? Don't be shy. Okay, so now tangent pi over 8 is the same with tangent pi over 4 divided by 2. And we have a formula. So let's go back. Let me share. Wrong mouse. Sorry. Let me share again. Where are you guys? Okay, here. I have so many windows open and okay. So here's one formula, right, for tangent alpha over 2. 1 minus cosine alpha. We did this a long time ago, which was 2 weeks ago maybe. Either this or this. It doesn't matter, you'll get the same answer. So 1 minus cosine of this top angle over sine of the top angle right here, or this one. It doesn't matter. Any preference? This or this? First or second?
Second.
Okay, perfect. I would agree. Sine alpha over 1 plus cosine alpha. So this is sine pi over 4 over 1 plus cosine pi over 4. Because that's my alpha. This is the alpha over 2. So sine alpha over 1 plus cosine alpha. Anyone remembers cosine alpha? I'm sorry, cosine pi over 4. What does it equal to? Sine and cosine. Anyone with me?
Are you talking about like the square root of 2 over 2?
Excellent. 1 plus the square root of 2 over 2. Very good. So the numerator is the square root of 2 over 2. The denominator is 2 plus the square root of 2 over 2. And we have to flip the denominator. So we have the square root of 2 over 2 times 2 over 2 plus the square root of 2. These two go away. You can, if you want to rationalize, that's fine. The square root of 2 over 1 times, I should write it as 2 plus the square root of 2. It's better. Multiply by 2 minus the square root of 2 over 2 minus the square root of 2 to rationalize this. Good. The numerator is clear. This has to go. The numerator is clear. The square root of 2, 2 minus the square root of 2. Can anyone give us a denominator? Can anyone multiply these two and give us the denominator? Anyone, please? Anyone? Can anyone multiply these two and give us the answer for the denominator? Is anyone with me?
Two minus the square root of 2 squared.
It's 2 plus the square root of 2, 2 minus the square root of 2. This is a plus b times a minus b. Can anyone give us the answer? I can't believe we got stuck on a problem that we did 3 months ago. Are we getting stuck on this?
Four minus 2.
Very good. Thank you so much for saving us. Indeed, 4 minus 2, which is 2. Excellent. Now, so this was the tangent 9 pi over 8. Now let's also look at cosecant 7 pi over 8. Any questions so far, please? Anyone? Anyone?
I have a question.
Yes, I'm ready.
How did you know it was pi over 4 at the beginning?
Because if I divide pi over 4 by 2, I get pi over 8.
Okay, thank you.
Thank you. Also, another indication was where we were asked to use a half angle identity. Good. Okay. For cosecant, can anyone give us the identity? Cosecant equals what? Because I don't want to work with cosecant, because I have an option that is much easier.
1 over sine.
Excellent, very good. 1 over sine 7 pi over 8. I need to determine this, and then I'll come back and put it here. Okay, so 7 pi over 8. Since we're limited, they're asking us to use a half angle identity. We have other options, but they're asking us to use a half angle identity. So I have sine ta over 2. What do I put at the top? Because they're asking us to use a half angle identity. What should we put at the top? This divided by this is this. And
7 pi over 4.
7 pi over 4. Very good. And again, this is a very nice angle, right? So now this is sine alpha over 2. So let's go back to the formulas for a second. So for sine alpha over 2, I have the plus or minus. It depends on the quadrant of alpha over 2, of this angle, which is 7 pi over 8. So the plus or minus depend on these, the angle 7 pi over 8 in our case. If it's an angle in the first or the second, sign will be positive, first and second quadrant. If it ends up being an angle in the third or the fourth, then I will have to use the minus. So for now, I'm going to just write plus or minus the square root of 1 minus cosine 7 pi over 4 over 2. I have to establish the sign. It cannot be plus or minus. It can be plus or minus. So one option would be to see where this angle is. So how do I do that? Where it ends. So 7 multiplied by 180 degrees, which is pi, and I divide that by 8. That will tell me the quadrant. It's 157 degrees 0.5. Obviously, it's in the second quadrant. Sine in the second quadrant, we already know it's positive, and I'm going to say only positive. So then I continue with positive. I'm emphasizing the positive. Now I have to determine cosine of 7 pi over 4. And remember, there are 2 pi over 4 here, 2 pi over 4 here, 2 pi over 4 here. So then that's the 7 pi over 4. Oh, I'm sorry. 2, 4, 6, 7. Sorry. So this is the 7 pi over 4. So it's in the fourth quadrant where cosine is positive. And since you already gave me the answer for cosine 7 pi over 4, in other words, the reference angle, what is the reference angle? I should have asked without jumping into conclusions. What is the reference angle?
Pi over 4.
Of course. That's why I rushed ahead and I said this is the reference angle and this is pi over 4. So that's why you already told me that this will be 1 minus what? And you already gave it to me a few minutes ago. Because the reference angle is pi over 4. Therefore,
Square root of 2
yes.
over 2.
Yes, perfect. Cosine 7 pi over 4 equals cosine pi over 4. Yes, which is the square root of 2 over 2. Excellent. Okay, jump over all this. Continue here. So it's 2 minus the square root of 2, everything over 4. Because I flipped the denominator already. 2 minus the square root of 2 over 2, flip, 1 over 4. And I can rewrite it like this. because I separate the square root from the top and the square root from the denominator. And this is it. Now, it's not finished because it was 1 over this. So when I put 1 over this quantity, I get 2 at the top and the square root of 2 minus the square root of 2 in the denominator. And this is it. And this is final. Any questions on these problems? Any questions? Any questions, please? Okay.